Good afternoon to everyone and welcome to this webinar that Laminated brings for you about products in the construction sites and for the applications. My name is Pedro Maldonado. I am an engineer of applications in Laminaire, and today in the afternoon I will be the moderator of this meeting. Right now we are going to share some instructions that are going to be really useful for the interaction during the webinar. It's definitely very important for you to have that. We are here to help. If you have any questions or you want to use your microphone, just let us know and we'll be ready to help. We also are going to have a Q&A session, question and answer session at the end of the meeting. And besides, at the end of the meeting, we will have a brief survey that we will really thank you if you can share it for letting us know all about all the experience. For you to be able to see the recording of this webinar, well, it's being recorded. Just you can look for our name in our social networks, especially where we are going to upload this video, but you can also find us in Facebook, LinkedIn, and Instagram as well. Well, now it's time to start with the engineer Felipe Trejos. He is our operations director, and he's going to be talking for us. Welcome, Felipe. Hello, Pedro and everyone. Good afternoons. I hope you are doing okay. I hope you enjoy this talk that we have prepared for you all. Well, right now I am going to turn my camera off. And just let me know when the presentation is being presented. Thank you. Here we go. We can see right now the presentation right now. Okay, good afternoon. I am the director of Laminaire right here. So this is a company that it's been in the market for about 35 years. We are manufacturing all kind of grids for supplying, and we've been getting into brand new products that are led to all what it has to do with ventilation, no matter if it's natural or mechanical ventilation or passive, with grids, for example, for facades, fronts, and some other elements like screen panels or architectural panels as well. Well, today we are going to see some louver grids, some general concepts. We are going to see what are the models that we can find, some success cases, and like we can see in our Revit family content. And then we are going to be talking about all the metallic fronts or facades, some uses, and some considerations that we need to have for the designs, and some designs that we have already done for our customers right now. So it's important to keep in mind the consideration for the presentation that Pedro mentions, and we can get started. Okay, so the ventilation or removing air, it's about replacing the dirty air, for example, in a place for fresh air in a specific place. So, well, we have a question, and the question is why we need to have some ventilation. Well, it has some advantages, and the reason is because it's going to eliminate the moisture, humidity, and some dangerous substances. And also, it's going to keep the healthy levels that we need to have in the different areas where this kind of grids or ventilation has got to be done. Ventilation by itself could be done by three different types. So one could be with the wind, the other one could be because of the thermic movements and mechanical systems as well. So we can see right now we can have the natural ventilation within the natural ventilation, which is used by bioclimatic designers and architects. And now, nowadays, with the changes of the technology, what it has to do with the energetic efficiency, it's being getting mixed, blended. It's all that it has to do with mechanical ventilation, with natural ventilation as well. And this is the idea is to be able to promote this energetic saving that all the buildings need up to today. So the natural ventilation uses the pressures of the air over the facades and the different temperatures. It does not consume any electricity. The volume of air are not guaranteed, and there are no mechanisms for energetic saving directly in order to because of the natural ventilation. So they are totally associated in the systems where there is no mechanical ventilation or any other kind of ventilation. Well, here's the other concept, which is the mechanical ventilation. For the mechanical ventilation, we have, as we can see right here, that this one use fans or ventilators for doing the ventilations. With this, then this air pass through some areas, which are the pipes in this case, and the abstraction could be produced naturally or it could be produced mechanically as well. So the advantages are that with this type of ventilation, we can actually control the pressure of the air, well, the admission of the air, and the air could be filtered as well, the one that is especially coming from the outside. For having the adequate ventilation, we need to keep three very important items. The first one is the heat dissipation. What are we going to do with the ventilation if we are going to dissipate heat, if we are going to dilute some toxic substances in the environment, if we are going to renew the air system for a better comfort, if we are going to transport elements, or if we are going to drive some pieces? Then we have a second item in which we are going to condition in regards to the amount or the volume of air that it's moving along. And we need to understand what is the need or necessity in regards to the rules or standards that have been already standardized in order to identify the changes of air that we need to have per volume in order to find the flow of air that is required in order to have this ideal ventilation. There is a third item, which is to determine those necessities for ventilation. And right there, what we are going to find are the possible requirements of ventilations, complementary accessories, pipelines, inside and outside. So this is in a general insight. Here we have the louver grids. And here we are going to define what is a grid, sort of grill, sort of fence. Well, this is a passive element and is a cluster of fixed elements that are adjustable, that has been developed probably in steel or aluminum, that generally are parallel. They are set in the same distance. It means that the distance between every single one horizontally or vertically, it has a distance defined by the manufacturer, and this distance has a specific purpose inside the grid or the fence. So this one could be located in the horizontally or vertically. They restrict or they permit the flow of air, sounds, and water, because we can have acoustic louver grids. They could be also the architectonical elements. They actually are very good to cut the sunlight. So there are many designs, and they are a very important element for the demands of the constructions in regards to ventilation, ventilation facades, gardens, patios, parking lots, and so on. And the louver has a big functionality because they can be opened in the exterior, permitting or blocking the sunlight and also controlling the light actually coming inside the building. And besides, there is a very good ventilation without penetration of water, only being an architectural device or element. So it's very important to keep in mind when selecting a specific grid to understand what are going to be the pressure fall downs, which is something very important for calculating the float and for having a process of selections, which has got to do very good because we need to keep in mind different accessories, for example, for restricting the water, birds, insects, dust, dirt, and some others. So the grid will have a different complexity when being selected and when being acquired. We also have several grids that are part of our portfolio. Here, in the second point, we can find what are the grids that we can find. So, for example, we have the first grids of the reference LR8, LP8. So right here, we can see the two references. We have two different products. This one right here, they have the same profile with this shape, but the change is right here in the past, and every single one has a different application, as you can see. So this one is like a mini louvert when it has this 8 millimeters gap, and it's a grid right here. And the type V, which is the one that I'm showing right here, is more used for ventilation than the louver, and we are going to see that eventually whenever we talked about specifications about the A500. So this one has a weight 5 kilograms per square meter and 4 kilograms per by square meter. It has a free area 48% and 56% in the type B. Velocity, maximum velocity of admission of water, I mean, particles, very, very small particles of water will be passing on. Those particles will be passing in the 21.6 kilometers per hour. That's the speed of the Earth in the type 8, and in the type B, when it's 1872 kilometers per hour, the speed of the Earth or air speed. And there is a classification. This classification shows that in regards to a test that is done to the product, this will show us what kind of classification the grid is going to be, starting on an A type and finishing in a D type. The type I says that it's a grid in which the water will not pass between 90 and 100%. The classification B means that the water in these velocities, 46 or 80 kilometers per hour, will not pass through the grid between in a 95 and a 99%. It means that this is a grid with a very good feature or classification ANC. So the other one is a grid that the water will pass between 85 and 95%. So we can see right here that more water will be passing between one side and the other side. So this is a grid that is more used for ventilation, and this one right here is more used, well, it could be used also for ventilation. It has less effective area, but it's completely, or it has a very good classification, ANCA classification, when it's used in facades. Then we can see the grid this type LRFA 146. What is the meaning for this? L is laminare, R comes from grid in Spanish, F from facade or facade in English, 146, which is the profile where we are manufacturing, and 8 is the past for the louver, and the B1 is for the ventilation grate. And the weight is 8.7 kilograms per square meter for the first one, and the other one is 6.5 for the second one. It's a free area at 42% and 48%. And the classification AMCA, that is a class C for the 8 and class D for the B. So these are some grids that could be used in ventilated fronts, in domestic uses and industrial uses. It could be also used for hot earths. Eventually, we will talk about these grids in real pictures. Then we are going to talk about this grid. It has some special features. We have a middle size and we have a big one as well, which is much more industrial, in which we can actually find the LOL4. This is a grid, is like type louver. The weight is bigger, is 10 kilograms per square meter, and it has an area of 54. The admission water speed is in the 21.6 kilometer per hour, and is classified, or its ANCA classification, for 46.6 kilometer per hour in the type B and 80.46 kilometers per hour in the type C. So this is for the industrial use. It could be used for industrial uses when we, for example, or when we need ventilation for machinery rooms where we have, for example, compressors, ventilators, fans, other technical chambers, or when we need to ventilate those kind of areas. So this is a grid that works very, very good for air with natural ventilation, and for different supply of air for extraction as well, and for supplying air as well. Well, then we have another type of grid. This is air blade. The name is LRFA 145. The weight we can see right here in this chart, because depending on the angles, we can have different weights. So these weights are between 23, 13, and 10 kilograms per square meter. These grids, they have an advantage. The advantage of these grids is that when we talked about the others, we have an effective areas up to 54%. But here we can actually talk of effective areas between 70, 78, and 64%. And this leads to something. The less area, we can have a grid that is giving actually the same volume of earth than with a regular grid or with a regular blade. So in the proportions of weight and price is a little bit more expensive, but with the other blades or with the other grids, we need a specific area, and with this blades, we need less area for getting the same amount of air. The classification ANCA is Class B, up to 46.6 kilometers per hour, and in Class C for 80.46 kilometers per hour. We have these grids that could be used in the floor. Those are the ones that could be used for providing air or supplying air through the floor. For example, it could be forced air, or it could be natural for air conditioning, or for natural ventilation. It has a weight of 14 kilometers per square meter and a free area 48% the applications, as I said before, is supplying airs, natural airs or forced airs in bioclimatic designs or in air AC designs by micro-weathered supplies. So here we have some successful cases that have been used, the ones that we showed before. So for example, we have this building that is the central point, Bogota city. You can see right here the grids or the blades. They are the LR8 LP. So this is a system that is called, is used for bioclimatic ventilation. And in this system, the air gets into some specific parts that makes that the air, that all this, let's say, contaminated air to come out by using some chimneys. And inside the building, there are some supply grids that actually deliver or the cold air to have more comfort. So we also have in these symphons, we have in the Pacific University in Lima, Peru, in the Catholic University, we have these grades also here, the LO4. We were talking before, those are grades or for technical rooms or machinery rooms. Here we have bioclimatic grades or blades for supplying and controlling air in all these access zones for personnel, for staff, where the ventilations by HVAC or AC or air conditioning is taken away. And with this kind of blades or grids, we can have the control of the air supply depending on the internal temperatures that we may have right there. So this is a warehouse. The name is Contecart. It's the Decathlon Cartagena warehouse. So they use this kind of blades or grids for supplying air over the facades. We can hear the front, all the accessories already set up. They are used for controlling the solid objects or animals not to get into the building. So right here we can see these grids, air blade. They are right here in the front of the building, used for ventilation, for natural ventilation in all these warehouses. And right here in the upper part, we can see the LR 146 type. Those are the ones that are long, 100, well, kind of long. And in the front side, we can also see this kind of grids or blade that could be used for air supply. For the grids that could be used for the floor, we can see it right here in the picture, as I showed before, LBG type. Right here, we can see a bigger proportion when they are used for air conditioning. I mean, with natural ventilation, we use bigger, first of all, because of the flow of air that is going to be managed, and second, because the air does not have any kind of mechanical element to move it. So it moves by its own pressures taken from the environment. This is located in Bogota, in the Paseo Villa del Rio is a mall. So we have these grates or blades right in here. As you can see right here, this is for extracting hot air. And this is for supplying natural air in the front sides of the building. Could be right here or in these horizontal elements that are set right here. They are also grids, ALRA, PA, for air supply in this commercial center. In our libraries, in the Revit libraries, we're going to see right here. In our Revit libraries, we can actually find different elements for, well, different elements or different families or products or systems. Products is only an element that has some specific features, weight and height, some limitation in the weight and the height depending on the modulations that we can do with these elements. And they turn into a system when this type of product, I have to set them in different or specific areas in some dimensions that are out of the regular form of the element. For example, when we talk about a product, it has some specific features in the families we are showing. What is the effective area, for example, if is required a frame wall, or is the frame wall is not necessary, the flaps type A or type B, what are the dimensions of the blades, and right there we can start doing in the families, like we start creating some systems. So a system, for example, we say I want to have this area with 27 meters long and 5 meters height. So right here it shows the wide width of 8 meters, and then all the cluster becomes a system, and this modulates the grids in order to obtain these measures by the designer or the architecture of the projects. Within these products that we have right now, they are developing products like the blades R8 146 and the grid air blade or grid 145. And yes, we have some other types of products that I showed before. So this is also part of the development in the design that we have in our portfolio. Right. So right here we are seeing some metallic fronts or metallic facades. Well, in the general concepts, the metallic elements or the fronts, there is an aesthetic evolution of the skins of the building. They have been promoting by the search or the quest of singularity. Because sometimes people want to make everything more minimalism, and also because of the necessities of the requirements of the customers. So when the metallic fronts, they are very elemental elements for different prototypes, for new techniques in the construction side that help us to adequate the contemporary constructions and the different requirements, flexibility and energetic efficiency. So this is all related with sustainability. So these are very light fronts, and they are very singular as well. They are here to become an element for closing residential buildings, for example, for reducing widths. They also allow some modifications through the time. It means that if at any time I do not agree or I'm not very happy with this front side, I can just change it without any kind of issue or problem. So we can always make some changes. And here we have these metallic fronts or facades, and these are the first image of the building, and it's like the present, like the business cards of the building. So that's the reason why this is the component that are generating a lot of interest among architects, engineers, and designers, and is one of the elements of the building where, in aesthetic terms, we have innovated a lot as a construction element in contact with the outside. These elements need to guarantee the capacity for being a barrier for protection of the spaces for inhabitants, and also it needs to have these aesthetic considerations and it also requires an optimal requirement or behavior for the skin of the building, depending on the different construction regulations. The presentations of these metallic elements, we can have different, located in different areas, for example, in the closing, or also in the different stratification of earth as a barrier for the light. They have got to be very resistant to the light as well, and they have to be reflective, or they need to have protection for the water and for the wind, and in some cases, depending on the kind of design, they have to absorb the noise. Well, the reasons for using these elements in the front part of the buildings, well, first of all, because they have to be very light, so they are not going to load the structure of the building, so it will reduce the weight of the buildings. Sometimes they are elements that are these are elements they are not part of the structure of the building, but they need to help the building by itself not to be overloaded with these type of elements, because of course they have some specific weights depending on the kind of element that we are working on. There is another concept that is a new concept, is the incorporation for wrap around or enveloping global, so we can have different singular elements. And the limitation right here of the functionality of these kind of elements is the minds, because we can have different type or many types of designs, and there are some other technical characteristics or features we are going to be talking eventually. And the metallic element for the front side help us to innovate with the designs or with the different changes that could be done in the future for the different elements. There is another subject that is very easy to mount, to set up these kind of elements. Gives they are modules. They've been pre-manufactured, so they are elements that, as I say before, they are industrialized, and by itself they provide very good features and characteristics in regards to the tolerance of the components when they are being installed, because everything it's it's an industrialized product, so they have standard measures where the errors and risks are minimized. And some other advantages is that they have an influence in the utilization of these elements, because they are a solution easy to replace, and they do not require a lot of maintenance, and they don't have a lot of impacts. And these materials could be recyclables. They do not produce any toxic products or residues, not even in the manufacturing and the installation, because when they are being manufactured, I'm talking about specifically in the laminaire. The processes that we use for these type of panels are very, very clean processes. So in regards with the cutting, bending, the metals, and the painting processes, as an enterprise, as a company, we have right now our responsibility, environmental responsibility, in which in any of these products we do not contaminate water, or we do not deliver elements to the earth, toxic elements. So here we have the elements we can work. We can use aluminums, galvanized steels, These are very good materials that you know, and they are very easy to work. Stainless steel as well is by itself aluminum is is a very ductile element, but is fragile than the galvanized compared with the galvanized steel. But this ductility that the aluminum has allows the aluminum to be used in this kind of projects. It's a very lightweight material, and when it's worked in different areas, the response is very good. We have also galvanized steels and could be used in different types of widths depending on the characteristics or features. The galvanized steel has a protection cover, which is a zinc protection cover that protects the element, that gives also the facility to be used in some areas where the aggression is intermediate. And stainless steel, well, is the best element, excellent element. Is a steel that, because of the chrome's levels, makes the material when is installed and in the application to have a bigger or better durability, because it's stainless. It does not need any covers. Aluminum and galvanized steels, they require a skin, a covers, and it's given by the electrostatic paints. In all the electrostatic paints that we have, like 3 or 4 products and different classifications, we can find paints epoxic because they are only for interiors, and hybrids paints that could be used inside and outside the buildings. Polyester paints as well that could be used for the outside of the building because they have a better resistance to the ultraviolet rays, and they can actually keep the colors much better through the time. And there are some applications in technology that provide very good features to the products in regards to the paints and the finishings. Well, colors in regards to the RAL for the provider suppliers, and not all the providers or suppliers have these developed. So what we do, we verify what are the colors that are developed that could be closer to the necessities. There is something very important, which is the screen. Well, the screen of a specific element, as we can see right here, is how much I need to take away. This elimination of materials in a shirt makes this to turn this in an effective area where the air is going to pass through, in a very effective area that by itself is an element that is also part of the selection of the product. So screen 40 means that I'm taking away 40% of the area to a specific area, or 50% or 60%. And I can translate this into light or ventilation. So, well, so we can use it for the front part of the buildings, for this kind of element, as we can see in the picture, or for separating some specific areas, as we can see right here in the picture. So what are the considerations for the design that we need to have? First of all, give me 1 second. Let's see. A structural calculus. Characteristics or features like locations, the shape, the weather, pressure, or air suctions, the weight of the systems, dilatations, the design as well, the definition of the system. Here we can talk about all related to the system. Right now, we are going to see what are the designs that we have established, the maximum measures modules, and so on. The fixing system could be different possibilities, the resistance as well. It has to do with how to hold all the weights and the wind loads. And there is also a subject seismo resistant, which makes we have to be able to define what is the material for having this proper resistant mobility as well. And sometimes they need to be moving for the secondary structure if they are in dilatation, or they can also be allow the thermic um, dilatation. They have to be adjustable in the three senses. Facility for repositions. The idea is to have a very good installation and a very good installation and the facility to replace where we need to simplify it, mounting and unmounting or changing some specific panel with having any problem, the resistance to the corrosion or erosion, because there are some specific pieces that could be done with some specific material, for example, steel or galvanized steel or stainless steel. And the environmental limitation makes it to be the resistance to the corrosion, or it has to be really, really careful with those elements that we are going to use when installing these kind of panels. Pre-treatment and treatment at the surface. We were talking about that before. We were talking about the paints. Something important for the paints is what is the pre-treatment that is being done to the surface before painted, before being painted, because sometimes people do not keep it into account, but it's a very important subject, because depending on the pre-treatment and the treatment that is done to the surface depends the life cycle of the product. Internally, we have a process, a pre-treatment in the surface that is called plaforizado. We use it by immersions. Is organic chemical which we have the panel inside this liquid, and it provides a sulfate layers or a cover to the product, and this gives the chemicals joints for the product to be joined to the surface where we are going to do the treatment, which is the paint. With this, we can guarantee certified more than 800 hours of products painted with these panels of steel, aluminum, and stainless. It's not necessary because those elements are very easy to use. Here we were talking about screen. We have some designs. Here I'm showing only 3, but we have 10 designs per every single screen. There could be more, and it depends obviously on the designs that we can find, because there are infinitive shapes, and every single architect or customer would like to have one or the other. So we can see this one. So for example, we have these 40 screens in which we are eliminating 40% of the area of a specific panel. The biggest dimensions of the panel is 1.10 and 2.155 meters. Well, here is in millimeters. So if we require bigger areas, we will need certain amount of these products in order to shape these modulations that can make this variation to be bigger, for example, or to be smaller depending on the measures that are required. We have some 50 screen, as I said before. We have like 10 designs in every single screen. And in the 60 as well, we have these different 10 designs as well with the screen 60. So the kind of quotation is depending the square meters. For example, this one has 2 meter, 1 and 1 meter, and the quotations that we have in the commercial area, they are done by, for example, square meter, by square meter. So the modulations is depending on the engineering department as well to be approved. Well, thank you very much. Now we have the Q&A session. Thank you. Well, I believe that. Okay, yeah, Pedro is right here. Yes, I am checking the questions again. We are inviting you to send the questions, and in the meantime, we are inviting you to follow us in Facebook, Instagram, LinkedIn, and specifically in YouTube, where we are going to upload the recording of these webinars. Right now, we have the first question, and this is the question. The size of 1.1 meter by 2.15 panel is the useful area. I mean, is the area that could be used. I mean, the panel has some bending, or to what is how it works. Yes, the panel has some specific bend for the installation, because this product has got to be set in some specific mounts that are organized in the type of modulation that it has inside the design. And there are some specific borders, let's say, to do it. And for all the screws not to be exposed, so you cannot see that where they are joined. And that biggest measure comes from the standard size in stainless, for example, in stainless steel or galvanized steel. So it has some specific folds. Each fold has a specific measure, and it depends on the panel and the material as well. Bending, fold. We have a next question right here. What kind of accessories or profiles are used for the installation? Well, for installation of the panel, there is a catalog that we are developing. Is a catalog and assembly in which we can have all the ideal profiles to be used. We have, for example, FDS or aluminum, with some specific elements that are manufactured and given by us for the installation. So we provide it. And we have a last question. We are inviting you to have, if you have any question about finishing or the available panels or any other kind of information that you may have. Here we have another question. How is the calculus of the perforation in the front facades that we saw in the last pictures, or is only an aesthetic subject? Well, let me see. Yeah, in these ones, right? In this one. Well, this is only aesthetic, but here we are talking about the area that I'm going to take away to the panel. For example, here we have a 60% taken away, so air or light that is going to pass through is the 60% of the area that it's impacting in this panel by itself. The same concept is used right here for 50 and 40 screen. So this also affects the light that is going to pass through or to a room, to an office, to the air that may come in, to the light by the thermic movement that may come in into a double front in a specific application, for example. And this also, we need to keep it into account the color, because the colors, of course, made these screen panels and black panels or gray panels or gray bodies that have reflection, or depending on the color, gray or black. I mean, I'm talking only the color, I'm talking about the thermodynamic painting. There is a transmission of energy because of the radiation. Well, we hope that we have answered all the questions. I will not mention the person because of the confidentiality, but maybe we complement. And yes, we have another question right here. It's key. The panels with the holes have hidden faults or bends. Yes, they do. The painting of the panels is before or after making the holes? After making the holes. Yes, is made after making the holes, because in the mechanized process or bending process, folding processes, making the holes, I mean, everything that has to do with the designs is done with the latest or the cutting edge technology with laser. And here we have the folding processes or the bending processes, which is not only for hiding the fixed element, but also to give mechanical resistance to the panel. So after everything is being done, we have the finishing processes, pre-treatment, for example, surfaces, and the subject of the applications of paintings and protection of the panel. Thank you. Next question. What is the gaps? What is like the gaps in the panels that have holes, for example? Let me show you. Well, this is a subject in which we are getting it. I mean, there are different types of gaps. Depending on the project, so it's like the junctions depends on the projects. There are different types of junctions, and it could vary. Like we can see right here. Yeah, we have the whole system right here, the panel, gaps, junctions. We can see right here how they are installed against the walls. We can hear the anchor system, hidden system, for example, here. Different perforations and screws. Here we have different profiles where the panels are like floating in this way, and it's totally hidden. And we can make easy changes, and everything is hidden. Yes, depending on the different types of projects. We have the different types of anchors. As you can see right here, inside or outside, depending if it's a front side or the side of the building, or if it's a wall where maybe we can cover something. So it changed a lot the different types of installations that we can see in that presentation. Well, it was very good answer. We have four more questions. We have a question here about the metallic elements with this finishing that seems to be oxidized, rusted. I mean, the question is if it does it has any impact on the environment when it's rusted or oxidized. Well, it does not. The finishing that is done to the steel to see like oxidized or rusted is a chemical process that is done to the product, is made to the product. Depending on the products, we can find different types of steels and we can work with it. Or we can actually buy steel, laminate it in cold, and we can do the chemical process to give this finishing rusted or oxidized, rusty. So this is what we can do with this type. But the process by itself is a chemical process that uses some different elements that um, we do not use that process. We don't have in this moment the installations for these systems. So it's a steel that could be gotten by itself in different widths, but we haven't worked with that one. So we are working with paints that are similar to these rusted or oxidized finishing. Not exactly the same, but very similar with very good results. Okay, thank you very much. This is the end of the Q&A session. Thank you very much for the questions. They are very valuable for us. And Felipe, thank you very much for the presentation and for answering to all the questions for attendees. And once again, we invite you to follow us in social networks to see the recording of this webinar if you want to check it out back again. And lastly, we are inviting you to check or to fill out the survey that is going to be right here presented. Felipe, thank you very much. Thank you very much. Hope it's been a great presentation, that this presentation complies with the expectations that you have. This is a subject that, I mean, it's very important, and I hope we have answered all your questions. If you have any question, of course, you have our commercial staff that will provide this information. Thank you very much. Well, thank you. Bye-bye.